Hello, this is Sal. Today's lab includes many of the skills that you have acquired during your study for the CCNA and the CCNA security. The routers and switches are pre-configured with basic settings such as IP addressing and routing. I will secure the routers using the CLI to configure various iOS features including AAA, SSH, and zone-based policy firewall ZPF. I will also configure a site-to-site VPN between router 1 and router 3. I will secure the switches on the network. I will also configure firewall functionality on the ASA. I hope my videos are helpful for those who are seeking to be certified for the Cisco exams. If you like my videos, please subscribe to my channel and share it on your Facebook page and give me the thumb up. And please let me know if you have any suggestions, comments, or questions. I will gladly answer you back. On the description of this video, you will find two files, one for the packet tracer source files and the documents to walk you through the lab step by step until you finally will be able to verify the configurations you did during this lab. Before you start doing the lab, run the show command on all the devices to see what have been pre-configured. I already configured and enabled also the security package on router 1 and router 3. Just like here on router 1, I will run the command show run. As you can see here, I configured the interfaces for the serial 00 and also for the gigabit ether net 00, and also configured the default route on router 1, and the same for on the routers, router 2 and router 3, and the PC with the IP addresses, except for the ASA device here. Just simply when you want to do, or when you start the lab, to do it on yourself and to follow the walkthrough documents, just run the command show run on the devices and just know what have been pre-configured there. Now I will configure basic router security. On router 1 here, configure terminal for the security password minimum length. Just for the simplicity of this lab, I'll use just 5. And encrypt plain text password, so service password to encrypt the service password encryption, and the privileged exec mode secret password is Cisco. Enable secret of Cisco. Now the console line password is Cisco. Timeout is 15 minutes, and console message should not interrupt command entry. So the command goes like this: line console 0 password of Cisco, and exec timeout of 15 minutes and 0 seconds for the login, and not to be interrupted, so the command of logging synchronous. Next, on router 2, enable configure terminal, the privileged exec mode secret password of Cisco. Enable secret of Cisco, and the password for the VTY lines is Cisco. Timeout is 15 minutes and login is required. So line VTY, the lines from 0 to 15, all 16 lines, password of Cisco, and exec timeout is also 15 minutes and 0 seconds for the login. Next, I will configure the switches. I will configure trunking between switch 1 and switch 2. I will set the mode to trunk and assign VLAN 99 as the native VLAN and disable the generation of PTD frames. So on switch 1, enable configure terminal. For the interface, the trunk between switch 1 and switch 2 on F01, pass Ethernet 01, F01, switch port mode trunk, switch port trunk native VLAN 99, switch port no negotiate. I will do the same also on router 2. Switch 2. Enable configure terminal, interface F01, switch port mode trunk, switch port trunk native VLAN 99, switch port no negotiate. Now back to switch 1. We have this port here, F06. Should only allow access mode and set to port fast and BPDU to be enabled. So on switch 1 on the port F06, interface F06, switch port mode access, spanning tree, port fast, spanning tree, BPDU enable. Now port F06 uses basic default port security with dynamically learned MAC address added to the running configuration. I will disable the port before I run the configuration. So we are still on switch 1 on port F06. Shut. I will shut down this port. Switch port, port security. Switch port, port security, MAC address to be sticky. Now I will enable the port with the no shut. Now all other ports on the switch, we are using only 2 ports here on switch 1, which is port F01, which is the trunk with switch 2, and F06. The rest of the ports, for security reasons, we need to shut them down. So on the interface range F02 to 5 and F07 to 24, because we are using port F01 and F06, and also gig 01 to 2 we are not using, they are unused, we want to shut them down. And when you are done with the configuring switch 1, just do the same on switch 2, but you need to configure the port F018 on switch 2. Next, I will configure AAA local authentication on router 1. I will create a local user account of admin1, a secret password of admin1, and a privilege level of 15 for this user. So back to router 1, exit. Now I will configure the username of admin1 just for the simplicity of this lab. And the privilege level for this user, we want to use the highest, which is 15, and with secret password also of admin1. Now I will enable AAA services. AAA new model. Next, I will implement AAA service using the local database as the first option, and then enable password as a backup option. So the command goes like this: AAA authentication. For login, the default login, use the local and enable, and then enable. Enter. Next, configuring SSH. I will configure SSH on router 1. I'll use the domain name ccnasecurity.com. So the command goes like this: IP domain name ccnasecurity.com. The RSA key should be generated with 1024 modulus bits. Crypto key generate RSA, enter, and we want to use the size of this 1024 bits. And on router 1 only SSH version 2 is allowed. IP SSH version 2. And only SSH is allowed on VTY lines. So line VTY, all the lines from 0 to 15, all the 16 lines, transport input only to use SSH on router 1. Now I will verify that PCC can remotely access router 1. So on PCC, type the command SSH link login as admin1 to 209.165.200.233, and the password we set for admin1 is admin1. Enable, and the password to enable on the router is of Cisco. So we were able to SSH from PCC to router 1. Exit. Next, I will secure router 1 against login attacks. I will configure the router that if a user fails to log in twice within a 30-second time span, to disable logins for 1 minute. So back to router 1, we'll exit from here. Login block for 60 seconds after 2 attempts within 30 seconds. Now I will configure router 1 to log all failed logins attempts. Login on failure, we want this to be logged. Next, I will configure site-to-site VPNs. I will run the show command on router 1 and router 3 to make sure that the security technology package license is enabled. So on router 1, exit, show version, just to double check, because I said I already enabled it on the router, and as you can see, the security package is been enabled on router 1 and the same on router 3, because this is where we will be running the VPN between router 1 and router 3. Enable, show version, and as you can see here, also it's enabled on router 3. Now on router 1, I will create an access list number 101 to identify interesting traffic on router 1, loopback 1 network to the router 3 on the port of gig 01 LAN. So from the source will be this network here on the loopback 1 on router 1, and the destination will be to the network of 172.16.1.0/24. This is the access list. So on router 1, configure terminal, access list, we'll give it number 101. We want to permit IP from the source of 172.16.10.0 on loopback 1 with the inverse subnet mask of 000.255 and the destination of 172.16.20.0 with the inverse subnet mask of this. Enter. Next, I will configure a crypto ASA CAM policy 10 phase 1 properties on router 1 and the shared crypto key of Cisco. So on router 1, the global configuration, crypto ASA CAM policy of 10. Now, the encryption of AES 256 and the authentication method will be pre-shared, the hash of SHA, and key exchange will use Diffie-Hellman in group 5 and IKE SA lifetime of 7,000 and ASA CAM key of Cisco. So now for the encryption AES, we will use the 256-bit key. Authentication pre-share hash SHA and the Diffie-Hellman group 5 lifetime of 7,000. Now I'll exit from here and configure the key crypto ASA CAM key of Cisco, as I said, and we'll use the same on router 3 and the address to share it with on this 10.2.2.1, this interface on router 3 on serial 001 of 10.2.2.1. Next, I will create the transform set of VPN set to use ESP AES 256 and ESP SHA HMAC, then create the crypto map, which I'll name it CMAP, that binds all the phase 2 parameters together. I will use sequence number 10 and identify it as an IPsec ASA CAM map. For the transform set, as I said, VPN set, transform encryption ESP AES 256, transform authentication ESP SHA HMAC, and the perfect forward secrecy PFS group 5. Crypto map name, I'll name it CMAP, all caps, SA establishment IPsec ASA CAM. And then I will bind the crypto map CMAP to the outgoing interface. So still on router 1, the command goes like this: crypto IPsec transform set, as we said, we'll name it VPN set ESP AES 256 ESP SHA HMAC. Enter. Crypto map, we'll name it CMAP 10 IPsec ASA CAM. The peer of This will be the peer here on this interface on serial 001 of 10.2.2.1. Set the peer of 10.2.2.1, enter, set PFS, group 5, no space, and set transform set VPN set, and to match the access list the address of 101, enter. Now we will exit from here, and it is time to bind the crypto map CMAP to the outgoing interface. So the outgoing interface will be on serial 000. So now on the interface of serial 000, crypto map C map, enter. Next, I will repeat the side-to-side VPN configuration on router 3 so that they mirror all configurations from router 1. So now on router 1, on router 3, I will create an access list 101 to identify interesting traffic on router 3 LAN network to the router 1 loopback 1 LAN. So on router 3, configure terminal. So now we will mirror everything, but this will be the source and this is the destination on the loopback 1 on router 1. So on router 3, create the access list, the same, 101. We want to permit IP from the source of 172.16.20.0 with the inverse subnet mask of 000.255 to the destination of 172.16.10.0 with the inverse subnet mask of this. Enter. I did a mistake. Access list 101 permit IP 172.0.40, no space. Uh, 000.255 and then enter. I did not leave a space between the IP address and the inverse subnet mask. Sorry about that. Next, I will configure crypto ISACAM policy 10 phase 1 properties on router 3 and the shared crypto key just the same as we configured it on router 1 of Cisco. Crypto ISACAM policy 10. Now, encryption AES just the same as we did on router 1, 256, authentication pre-shared, hash, SHA, and the Diffie-Hellman group 5, and the lifetime just the same of 7,000. Now, time to configure the key, crypto ISACAM key of Cisco, and to the address of 10.1.1.1. This interface here on serial 000 of router 1 and hit enter. Next, I will create the transform set of VPN set to use ESP AES256 and ESP SHA HMAC. Then create a crypto map CMAP, just the same as we configured it on router 1, that binds all of the phase 2 parameters together. I will use sequence number 10 and identify it as an IPsec ISACAM map. So now back to router 3. The command goes like this: crypto IPsec transform set VPN set ESP AES 256 ESP SHA HMAC. Enter. Crypto map CMAP 10 IPsec ISACAM. The peer for router 3 here for this interface will be the one on 10.1.1.1. Enter. Set the BPFS group 5 and the transform set of VPN set, and this to match address of access list 101. Enter. We will exit from here. Now I will bind the crypto map CMAP to the outgoing interface, which will be on the interface of serial 001. So interface serial 001 crypto map C map. Enter. Next, I will ping the loopback 1 interface 172.16.10.1 on router 1 from PCC on router 3. So from here, I will ping 172.16.10.1. It should be successful. This will prove that the VPN, IPsec VPN tunnel is. Now I will run the show command, show crypto IPsec SA, to verify that the number of packets is more than 0, which indicates that the IPsec VPN tunnel is working. So here on router 3, I will run this show command, show crypto IPsec SA, and as you can see here, it is the packets encapsulated 3 and encrypted 3. So our the tunnel is working perfectly. Next, I will configure firewall and IPS settings, intrusion prevention system. I will configure a ZPF on router 3. I'll create zones named in zone and out zone. So on router 3, configure terminal, zone, security, in dash zone, exit, and now zone, security, out dash zone. Enter. Next, I will create an access control list. I'll give it the number of 110 that defines internal traffic, which permits all IP protocols from the 172.16.20.0/24 network, source network, to any destination. So exit from here. Access list, I'll give it number 110 to permit IP from the source, which is of 172.16.20.0 with the inverse subnet mask for this network of this to any destination. So we want to permit this network to go to any destination. Enter. Now, access list 110, we want to deny IP from any other network to any destination. So the implicit deny. Next, I will create a class map named internal dash class dash map that uses the match all option and access control list 110. So class map type, inspect, match, dash all, and the name internal dash class dash map. So I created the class map, enter. Next, I wanted to match the access group, which we created the access list of 110. Enter. And I'll exit from here after we are done with the configuration. Next, I will create a policy map named in to out pmap that uses the class map, which we configured internal class map, to inspect all matched traffic. So the command goes like this: policy map type inspect in dash to dash out dash policy map. Enter. Now for the class type, inspect the internal dash class dash map. Enter. What do we want, to drop it or inspect? We want it to inspect. Enter. Now, as you can see here, no specific protocol configured in class internal class map for inspection. So all the protocols will be inspected. So exit and exit. Next, I will create a zone pair named in to out Z pair that identifies in zone as a source zone and out zone as the destination zone. So zone dash pair security in dash to dash out dash Z pair. So the source will be in zone and the destination will be out dash zone. Enter. Next, I will specify that the in to out policy map, which we named it as in to out P map, policy map, is to be used to inspect traffic between the two zones. So service policy type to inspect in dash to dash out dash P map. Enter. Next, I will assign the port gigabit 01 as end zone. This port here, this will be the end zone, and the serial 001 will be the out zone. So interface gig 01, enter. Zone member security in dash zone, the interface of serial 001, zone member security out dash zone. Enter. So we are done with this configuration. So I'll run this command, show command, show zone security. As you can see here, it is giving us where is the end zone member interface on this interface of gig 00 and the out zone of the serial 00 1. Next, I will configure an IPS on router 3. Where we have a note here because within Packet Tracer, the routers already have the signature file imported and in place. They are the default XML files in Flash. For this reason, it's not necessary to configure the public crypto key and complete a manual import of the signature files. So I'll show this here on router 3. Run this command, show flash. As you can see here, it's been done for us already on the router. Next, on router 3, I will create a directory in Flash named IPS dir and set it as the location for IPS signature storage. So from here, type the command mk, which stands for make directory dir IPS dir, enter, and then create the directory file name, just hit enter. Now configure terminal IPS config. The location we want it to be in Flash colon IPS dir, enter. So let me exit from here and see if we created show flash, and as you can see, this is what we created now. Now I will create an IPS rule named IPS-rule. Configure terminal IPS name IPS-rule, enter. Then I will retire the all signature category with the retired true command, all signatures within the signature release. So the command goes like this: IPS signature category, enter. Now we want category all, enter. Retired either false or true, we want to return them, so the command true. Then I will unretire the iOS IPS basic category with the retired false command. So category iOS IPS basic, enter. Retired false, enter. Next, I will apply the rule inbound on the interface of serial 001. So exit, another exit, and then hit enter to confirm. Now on the interface of serial 001, IPS, the rule we named it IPS-rule, and inbound, enter. Now I will run a few show commands. You run them and also study. Show IPS all. Here, just read it carefully, or have a look. Gives you everything we configured, but with Packet Tracer, what is allowing us to read: IPS category CLI configurations, category all, retire true, category for the iOS IPS basic, the retire false. And another show command, show IPS signature count. Total compiled signatures is 1. This is what's given us. And another show command, show IPS configuration. Just have a look at this command and study it. Next, I will do the configuration for the ASA Basic Security and Firewall Settings. Now, with this big guy here on the ASA, enable, no password, just simply hit enter. For the VLAN 1, sorry, configure terminal, enter VLAN 1, IP address of 192.168.10.1 with a subnet mask of 255.255.255.0. Name of the interface is inside, and the security level of 100. Next, I will configure VLAN 2, but I will remove the default DHCP just to be sure of it. The default DHCP settings, and configure the addressing to use 209.165.200.234 with a subnet mask of 255.255.255.248. So now on the enter VLAN 2, name if outside, enter, security level of 0. Now no IP address DHCP, but we will configure this IP address for VLAN 2 of 209.165.200.243 for this interface here, and /29. Subnet mask 255.255.255.248. Enter. Exit. We want the host name of ASA and domain name of ccnasecurity.com, and enable password of Cisco for this lab simplicity, you know. Next, I will create a user and configure AAA to use the local database for remote authentication. The local user account named admin1 with the password of admin1, but you need to be more careful with the username and the password. But for this lab, I'm using something really to memorize and to remember. So for the username, I'll use admin1, and the password of also admin1. Enter. I will configure AAA to use the local ASA database for SSH user authentication. So the command goes like this: AAA authentication SSH console to use the local database. Enter. Now I will allow SSH access from the outside host. To SSH, this is an outside host, just this host. Only this PC is allowed to SSH to the ASA. So back to ASA device. So Now I will allow the SSH access from, as I said, the outside local, the outside host of 172.16.20.2 with a timeout of 10 minutes. First, I will configure the inside network for the SSH. So we want to allow this PC, outside PC, to SSH to this network or to this on the ASA. So the command goes like this: SSH to the network of 192.168.10.0 with a subnet mask of 255.255.255.248. Oh, sorry. .0, and this is inside. Next, I will give the outside host the permission to SSH to the inside network. So SSH 172.16.20.2 with the subnet mask of 32 because just one host. So the subnet mask of 255.255.255.255 outside. Enter. And SSH timeout of 10 minutes. If he is away from not using the SSH connection, just to time him out for this user. Enter. Next, I will configure the ASA as a DHCP server for the inside network. So DHCP, the address for 192.168.10.5, this is the pool of addresses to 192.168.10.30, and this is for the inside network. Enter. Next, I will enable the DHCP to listen for DHCP client's requests. So DHCP D enable for the inside network. Next, configuring static routing and NAT. I will create a static default route to the next hop router 1 IP address from the ASA. From here to this interface here, this is the next hop or the gateway for the ASA. So route to the outside to anywhere 000, any network with this subnet mask, and the next hop will be on the interface of 209.165.200.233. Enter. Next, I will create a network object named InsideNet and assign attributes to it using subnet and NAT commands. So object network, name it inside dash net, enter. Subnet, the subnet of 192.168.10.0 with /24 subnet mask, and I will create a dynamic NAT translation to the outside interface. So we want it to NAT inside to outside dynamic and the interface. Enter. Now I will modify the Cisco Modular Policy Framework, MPF. So I'll exit from here, and on the ASA, I will configure a class map inspection default to match the default inspection traffic, and then exit to a global configuration mode after I am done with this configuration. So here, configure terminal, class, map, inspection, default, enter, and we want this to match the default inspection traffic, enter. Now I will exit to the global configuration mode here, exit. Then I will configure the policy map list global policy. Then I will enter the class, which is inspection default, and enter the command to inspect ICMP. After that, I'm done with the configuration. I will exit back to the global configuration mode. So policy, map, global, policy, enter, class, which we configured inspection, default, and enter, inspection default. Class, inspection, inspection default. I did a mistake here. So this is the name of the class map we configured. So I will do it with like this, you know, even with the typo, default. So just to show you to be careful with the name, and it will take only the name you are giving it. So I'll run the command again here, class inspection default, not FAULT, enter, and it took it here. So be careful. I'm supposed, you know, to not to do this typo, but I did. But as I showed you, it will take the name you configure for the class map or the policy map. Now we wanted to inspect. Inspect what? We have so many protocols. As I said, we wanted to inspect only the ICMP. Enter, and I'll exit from here. Now I will configure the MPF service policy to make the global policy apply globally, which means globally on all interfaces. So service policy, global policy, and we wanted to do it on all interfaces, global, enter. Now I'm done with the configuration. You know, as I said, download the source files on the description of this video and the walkthrough. And as I said, first run the show commands to know what I pre-configured beforehand, and then do the configuration according to the walkthrough and this video. Thank you so much for watching. If you like this video, please subscribe to my channel, and I will be working on new videos with the new Cisco exams. Just send me suggestions and I'll make the videos for you to help you passing whatever exam you are going to take. Thank you so much for watching. Give me the thumb up please on this video, and subscribe to my channel, and share this video on your Facebook page. Thank you for watching, and I'll see you soon in my next video. Have a nice day.